What is up, Precalculus? This is lesson 52. Our objective for today is how do you use Cramer's rule to solve systems of equation. There's a little bit of background in your book there on page 266 if you want to figure out who Cramer is and some interesting information about that. But for the video, just to keep it short, we're going to jump right into this and kind of show you how to use it. This is Cramer's rule. It says if you have a system of equations, this is for two variables. There is an extension of this for three variables, but for today we're just sticking with two variables. Where you have ax plus by is equal to e, and cx plus dy is equal to f. This is any system of two variables here. Then if you define d sub x, and d sub y this way, all you have to do is find your x and your y by doing this. So let's just look real quick. D is just what we call the coefficient matrix. And particularly, it's the determinant of the coefficient matrix. So remember, this is just a simple number, right? A times D minus C times B. And notice this one is quite similar to this one, with the exception of one thing. The column that has the x's in it, the variables by the x's, since I'm looking for the d sub x, instead of using those variables, or instead of using those constants, those numbers from the equation, we're going to use these ones over here, the e and the f, like the constants from that equation. So e and f here in for the x column whenever I'm looking for x. And whenever I'm looking for y, I'm going to put those variables into the y column. So notice, so then x is just this d sub x over d, and y is equal to d sub y over d. It's that ratio. So notice as you go in there, so we're looking for the x, we're using these ones right here in the x column, and over here in the y column when we're looking for y. Now, if you'll remember back from solving systems of equations in two variables, there are two special cases. The first one is whenever you have two lines that are actually just right on top of each other. Because remember, as you're solving these, you're looking for a point that they have in common. Most of them are going to be like this. You're just looking for that one point right here that they cross, the one point they have in common. Some cases have two lines that are essentially the exact same equation, and so they have infinitely many solutions. Okay, they're all on this line because those are overlapping. And then the third option is whenever we have parallel lines and they don't ever cross. That's when we have no solutions. And these we can find in Cramer's rule as well. Notice we have a ratio here, and we know that ratios are undefined if the denominator is equal to 0. So whenever you're trying to solve a system like this and your denominator is equal to 0, you can't really solve it. So that means you're going to have one of these two cases. So first sign is if your d, the determinant of the coefficients, if that comes out to be 0, then you know, okay, I'm going to either have infinitely many solutions or no solutions. And here's how you tell. If these other two both equal 0, again, I'll say it again, if these two both of them equal 0, then that's when we would have infinite number of solutions. So it would look like this, two lines that overlap. And you also could tell it from here, you could realize that these two equations are actually the exact same. It's infinite number of solutions. But for this lesson, you'd still want to go through this because it says use Cramer's rule to show this. So if they're both equal to 0, so essentially if all three of these are 0, then you know that you have an infinite number of solutions. You have no solutions if this one's equal to 0 and one of these is not equal to 0. So if this one's equal to 0 and this one's equal to 2, then you would say, oh, no solutions. Or if this one's equal to 0 and these two are both equal to some other number, then you'd say no solutions. The idea is if all three of them are 0, infinite. If this one is equal to 0 and one of these two is not, then you have no solutions. All right, so now let's go ahead and try some of these. These are the first 4 from your worksheet. If you have not gotten your worksheet yet, pick one up. They should be at the back of the room. So I'm going to start here with number 1 here on your worksheet. I think you just have 10, so we're doing the 4 on the front page with you. You're going to do the back 4 or the back 6 on your own. So let's see if we can set this up. We know x is going to equal to a ratio. The bottom is going to be 3, -6, -1, -5. Determinant of that. The top is going to be that -27, -19, and then the -6, -5. So again, this -27 and this -19 came from right here. This -6 and -5 came from right here. And these are just the coefficients, 3, -1, -6, -5, are how we get this. Alright, so you just say 27 times -5 minus -19 times -6 over 3 times -5 minus -1 times -6. Simplifying those down, you get 21 over -21 is equal to -1. So that's my x value. That's what x is equal to. My y value is going to be 3, -1, -27, -19 over, notice, we use the same denominator here, so I'm going to say minus -21 there. That's going to equal to, same idea here, 3 times -19 minus -1 times 27. It comes to be -57 minus 27, so -84 over -21, which comes out to be +4. So my answer, my solution, is the point that those two lines cross when x is -1 and y is 4. Okay, let's try another one of these. I already have this wrote in here. So notice these values over here, the constants, go in for the x column and for the y column. And let's just see if we can expand this and simplify. Alright, if we simplify this down, you can notice this times this minus this times this. We get 0 minus 0. We have -3 times 6 times 6 times -3. And that comes out to be -18 minus the -18 or +18. So we get 0 over 0. Now this expression right here is undefined. It's undefined. So this does not give us a value of x because my denominator comes out to be 0. But that tells us then that this is either going to have no solutions or infinite number of solutions. So the only thing we need to check then at this point is this numerator right here. We already found out that this one is 0, so we need to find out if this one is 0, then we would have infinite number of solutions because all 3 of those would be 0. If this comes out to be a number, then we'd have no solutions. So let's just check that real quick. So notice as we work that out, we end up with 0 minus 0, which is 0. So that turns out that the d sub x, the d sub y, and the d are all 3 0. That means I have infinite number of solutions. Alright, let's do a few more here. Again, maybe pause it if you need to see, make sure you know how all these numbers got here. Let's see if we can work this. So as we work these out, we can say 3 times 5 minus -25 times 3. That's 15 minus 75. The denominator is -3 times 5 minus the -3 times 5. So it turns out to be -15 minus -15. So notice the numerator comes out to be -60, the denominator comes out to be 0. Since the denominator is 0, this expression, this whole thing, is undefined. So we will not have a solution for this. We'll either have infinite or no solutions. And since this numerator, since this one right here, is not equal to 0, remember just one of these has to not be 0, we would know that we would have no solutions. This is a case of parallel lines. Okay, here's number 4, the last one on the front page, and then you'll continue to work through there on your worksheet here. So If you simplify this, you get negative 3 minus 25. It's negative 28. This bottom one's negative 32. So that reduces down to 7/8. Now notice this denominator and this denominator is the same, so we can just use that negative 32 for this denominator to save us a little bit of work. So working this one out, you end up with that negative 20 minus a negative 4, so it would be like saying negative 20 plus 4, which gives me that negative 16. The negative 32 in the bottom, reducing that, you get 1/2. So my answer, the x, is going to be 7/8, and the y is going to be 1/2. Alright, again, your homework is that worksheet that you probably already have in your hand. Finish that out. We'll grade it tomorrow. Good luck.